Okay, so on to a different example. So consider the problem of sketching the curve given by the parametric equations x equals 2t minus 4, y equals 3 plus t squared. And now this is an example where the interval for t is not given, so you just assume that it's all real numbers. Okay, and in this case, we still need to construct a table. Okay, and what we do is we pick values of t, I guess, near 0. Okay, so I'm going to pick some values of t that and compute our x's and y's. So I have a column for t, a column for x, a column for y, and I'm going to choose t equals minus 2, 0, 2, and 4. Okay. And there's no set way of doing this. You might have chosen increments of 1 instead of 2. We're going to go with this. Okay, so if t is minus 2, what is x? So I plug minus 2 into 2t minus 4. We get minus 8 for x. And for y, of course, minus 2 squared. The quantity squared is 4. 4 plus 3 is 7. So this is a point on this curve. Plugging in 0 gives us minus 4, 3. Plugging in 2, x is 0, y is 7. Plugging in 4, we get the point 4 and the point 19. Okay, so try to plot these points. Here's our x-axis, here's our y-axis. So we have the point 4, 19. Okay, so I will mark off here as 4, and 19, let's say, is way up here. So this is 19. So let me. All right, so I moved my point 419 over a little bit just to make a better graph. If we plot the point 0, 7, and I guess I'm plotting from the bottom up in our table. Nonetheless, if we plot the point 0, 4, it would be somewhere, let's say, around here. We plot the point minus 4, 3. Looks like it would be somewhere around here. And then if we plotted the point minus 8, 7, we would be somewhere around here. Okay? And if we filled in these points, and actually, I plotted them in the reverse order. If we plotted them in the correct order, we would have, I connect the dots, this is what we have. And if I get a sense of what this curve is, it's actually a parabola, so I'm going to fill in some more of the details. If we had plugged in, let's say, other points, we would get this parabola here. And it does have an orientation. If we think of t going from minus infinity to positive infinity, the orientation would be in this direction. Okay. So this is really a parabola that we just plotted here. This is the plane. The plane curve is a parabola. Right now, how can we see this from these parametric equations? Well, there's a thing called eliminating the parameter, which basically takes us from the parametric equations that describe this planar curve to a curve given by y as a function of x. Okay. Now we can't always eliminate the parameter, so let me just note that. So we're on to eliminating the parameter. And so I'll just note It's not always possible. Alright, so I'm just going to use our previous example. So let's write x equals 2t minus 4, and y equals 3 plus t squared. And so what we want to do is we want to solve for t in terms of either the x or y. And if you look at the forms of these functions, it should be clear to you that we should be solving for t in terms of x. Okay, we have a t squared, which when we take a square root, we have to be careful about plus minus sign. We're going to solve for t using the x equation. So if we solve for t using our equation for x, we would add 4 to both sides and then divide by 2. So t equals 1/2 x plus 2. Okay, so we just added 4 to the equation and then divided by 2. And now we substitute into y. And so y equals 3 plus, and now using parentheses, 1/2 x plus 2 quantity squared equals 3 plus, if I FOIL, I get a 1/4 x squared. And so the insides and outsides would lead to a plus 2x. And then finally, the last would be a plus 4. And then, of course, we can simplify this and write this as 1/4 x squared plus 2x plus 7. So this is the parabola that we actually plotted above. Okay, so now I'm going to discuss the parametrization of a line in the plane. And so, if we consider two different examples, so I'm going to consider the line through a point AB with slope m equal to, let's say it's a ratio s over r. Now, if you were given a slope that it was just, let's say 3, of course you can write 3 as 3 over 1. Okay, so in this case, the line, we can parametrize this line through this point with a slope equal to s over r this way. X equals a plus rt, y equals b plus st. And let me be clear up above that r cannot be 0, of course. And this is parametrized for t between minus infinity and infinity. Okay? And if we're given 2 points, of course, we can, if say we have a line through the points A, B, and C, D. What is m? Well, m is of course a delta y over delta x, which equals d minus b over c minus a. And so we can take those, or get the numerator as s, the denominator as r, and we can write our parametric equations this way. X equals a plus t times c minus a, and y equals b plus t times d minus b. And of course, we still have t ranging between minus infinity and infinity. So an example, once we have these equations, the example is quite simple. So we're going to find the parametric equations. For the line through the point 3, -1, with slope m equals 4. Okay. So going by what we have from above, we can set s equal to 4, r equal to 1, and write down our solution as, so if we write m equals 4 over 1 and set this equal to s over r, we can fill in the details and say x equals 3 plus rt, which is 3 plus t, and y equal to -1 plus 4t. Now this should make sense. The way where we place s and r should make sense, since for each increment of t, each unit increment of t, x moves to the right by 1, y moves up by 4, and so that would give us something that has a slope of 4. And so this would be the parametrization, and we could plot the line, but I'll leave that as an exercise.